Hey folks, how's it going? In this video we're going to look at how to answer open-ended questions in physics, and this is relevant to all National 5 higher and advanced higher pupils. So let's get into it. So we'll start with an introduction to see what open-ended questions involve, and then we'll look at the marking criteria to see how you can achieve the best marks. We'll then look at some common types of questions that have come up in past papers before, and then we'll look at a mind map for things that you should be including in your responses to open-ended questions, and then we'll finish by looking at 5 top tips on how to answer open-ended questions. First of all, you probably already know that open-ended questions begin with the phrase use or using your knowledge of physics, and you will be given 2 of these questions in the exam paper. The questions can cover any physics concept that you have learned about during the course, and you may need to use knowledge from more than one topic area to answer the question. And that may seem like it's difficult to do, but once you've studied everything for the final exam anyway, you should then have all that knowledge to use to answer the question. We'll now look at the marking criteria to see how marks are actually awarded. So we say that marks are awarded based on the following criteria. So 3 marks are for showing good understanding of physics in your response. You get 2 marks if you show a reasonable understanding of physics. You get 1 mark for a limited understanding, and lastly 0 marks for showing no understanding of physics. And the answer does not need to be excellent or complete to achieve full marks, so you can get 3 out of 3 marks just for having a good response, showing a good understanding. It then says here that SQA markers use positive marking and judge your response holistically, and holistically just means overall in a broader scale. So this means that no marks are removed for an incorrect statement. So you could have some incorrect physics in your response, but as long as the rest of your response shows a good understanding of physics, then you could still get 3 out of 3 marks. Obviously, you'd want to try and limit how many incorrect statements you have in your response, ideally with none, because you want to make it as easy as possible for the marker to give you full marks. So what types of questions have come up before? Well, I went through all the past papers for National 5 Higher and Advanced Higher Physics, and I looked at the kind of questions that they were asking. And the majority of questions I found in the past have started with the phrase, using your knowledge of physics, comment on. So they usually want you to comment on something. And here's a list of all the things they've asked you to comment on in the past. So you might be asked to comment on the benefits and/or risks of something. You might be asked to comment on the similarities and/or differences. The statements or these statements if they give you more than one. So it could be statements made by a pupil or a teacher, for example. You could be asked to comment on why something happens or how something happens. You could be asked to comment on possible explanations for something happening. You could be asked to comment on situations. You could be asked to comment on the challenges faced or involved in a certain situation. You could be asked to comment on the suitability of the design. So there could be a sort of experimental setup, for example, that you have to comment on. You could be asked to comment on possible factors. You could be asked to comment on the analogy, which I've seen come up in lots of higher physics open-ended questions before. And remember, an analogy is just a way for you to remember a certain concept using a different concept. You could also be asked to comment on the system, the model, or the diagram. So for example, if a question gives you a diagram, that's a really good starting point because you're able to use the diagram and comment on parts of the diagram. So you're able to say if certain parts of the diagram are correct or incorrect and why. And that can then inspire you to think of different things for your response. And lastly, you could be asked to comment on the conversation. So for example, a question might have a conversation between 2 people and you have to comment on whether the statements are correct or incorrect. And it's worth pointing out that first one there, the benefits and/or risks, is sort of just like an advantages, disadvantages kind of question. Moving on, now what kind of things should you be including in your responses? Well, if we start with the first one here, definitions. Based on the question, if it's asking you about a particular part of physics from your topics, then you'd maybe want to start by defining what that thing is. So for example, if the question's about nuclear fission or nuclear fusion, then it would be a good idea to start by defining what nuclear fission or nuclear fusion actually is. What else could you include? Well, you could include equations and units. So for example, if the question was about capacitance, then you could include the equation relating capacitance, charge and potential difference. Or if it was about speed, distance, time, then you could include the equation d equals vt, and you could say what the symbols represent. So d is distance, v is speed, and t is time, and you could say what the units are for each of those variables, because that way you're showing your understanding. Next we have diagrams. Now diagrams are a great way of showing your understanding of the physics involved without having to write too much. So it could be that you're struggling to think of lots of statements to write in your response, or you might just be better at drawing pictures. Then in that case, if you think diagrams are going to be suitable for the particular question, then I'd 100% recommend drawing a diagram or doing some kind of sketch that you then label, so that you can try and pick up marks that way as well. Because often diagrams will help to support what you've written next to it, but I'd avoid just drawing a diagram on its own. I'd give some text next to it as well. We also have explanations and descriptions. So you might need to explain certain things or how certain physics works. And you might also need to describe what's going on. And so it could just be a picture that you're picking out parts from and describing. We then have sample calculations. Now, what does that mean? Well, if you're given numbers in a question, then chances are they want you to use those numbers in some way. So they probably want you to choose an equation from the relationship sheet and write it down and use the numbers that they've given you in the question to try and calculate something, to then talk about it to prove whether something is true or false, for example. So just be aware that if you see numbers in an open-ended question, they probably want you to use the numbers in an equation. And it will hopefully be obvious the equation to use based on the physics involved. And lastly, we have answer the question. Now this might seem obvious, but you'd be surprised at how many pupils gain 0 marks for the open-ended question responses, and it's because they just don't go back and answer the actual question. There's no point in writing lots of correct physics down on your page if it's not got anything to do with the actual question. So if it's asking you to comment on something, then you need to make sure you come to a decision. So for example, if it gives you a pupil statement and it asks you to comment on it, then chances are they want you to agree or disagree with the statement. Now, you don't need to fully disagree or fully agree with it. You could say you partially agree with it and you partially disagree with it, as long as you justify why. But that way you're answering the question, you're commenting on the actual statement that's been made. And you need to make reference back to the statement itself. So try to remember not just to write down correct physics, it needs to be linked to the question, and I'd always maybe write down a little conclusion at the end which does link back to the original question, because that way the marker is going to know that you have actually read the question and know what's involved. Lastly, we'll just look at my 5 top tips for answering open-ended questions. And again, this is applicable to all levels, National 5, Higher and Advanced Higher. So number 1 is to leave these questions until the end when or if you have the time. Now the reason I say that is because a lot of the time pupils will try and write so much for the open-ended questions that they then don't leave themselves enough time to answer the main questions in the question paper. The 2 open-ended questions, remember, will only total 6 marks out of your entire exam paper, which will likely be more than 100 marks for all levels. So that means the marks coming from open-ended questions will be about 5% of your entire paper or less. So it's a good idea to try and get as many of the other marks as possible, because there's lots of calculations in the paper, there's lots of those state and define questions and explain questions and so on, and it's worth you spending the time on those as well as multiple choice and trying to pick up as many marks as possible, and then coming to the open-ended questions at the end once you've got the time. My second top tip is that you do not have to answer the question in an essay format. Bullet points are fine. So if you prefer jotting down bullet points, if it helps you sort of structure things better, then avoid going for an essay type format. And if you are going for bullet points, just make sure you're not just listing things, make sure you actually explain your points as well, because you're going to get marks for showing your understanding of the physics involved, not for listing as many things as you can remember. My next top tip is that drawing labeled diagrams can be a useful way to demonstrate understanding and will also score marks. Now I did mention this one earlier, but labeled diagrams can be a great way to show that you understand something. So I'd maybe always try and think about how you can support what you've written with a labeled diagram as well, because that's going to show the marker that you really know what you're doing. The next top tip is to try to write down as much correct physics as you can that answers the question. Now this might sound a bit obvious, but remember we mentioned earlier that you want to try and avoid writing down incorrect physics statements and try and give as many correct physics statements as you can. And you also need to make sure they answer the question. So remember we talked about linking back to the question. And that then brings us to number 5, which is remember to answer the question by relating back what you have written to the wording of the question. So if it's asking you to comment on a statement, mention the statement and conclude your answer. And lastly, one bonus tip for you is that if the question is to do with, say, advantages and disadvantages, or benefits and challenges, or similarities and differences, and you have to comment on those, then a lot of pupils are tempted to draw a table and to start listing things down either side of the table, say similarities on one side and differences on the other side. Now, this can be a good thing to do to get you to structure your answer. However, make sure you're actually explaining each of your points rather than just listing a few words down in each column, because that way you're not really showing your understanding. You're just showing how many key phrases you've remembered, and that's not really explaining what you know. So if you are going to go down that route of drawing a table, make sure you're explaining things as you go down. So it might look more like sentences going down your table rather than just words or phrases. And that way you're going to pick up more marks. And lastly, good luck when you come across open-ended questions in the exam. That's all for this video, folks. Thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a like, subscribe to the channel, and I'll see you in the next one. Take care.